Hello guys. So in our previous lecture we have added three methods over here in our blockchain congress. So we have actually called a method called add a member, which has been defined in this congress for the adding a member into the membership or whatever the data structure where we are keeping track of the members. So we have already have the member structure over here whose array has been defined with the function name called members. So we need to make sure when the member has been added, it has been added in the members array which is defined inside the contract. So to do that, first thing we need to do is, of course, while adding a member, you need to check what is the target member, what is the address of the member you want to add or the admin want to add, and what is the member name. So these two things are only required. So to start with, first thing we need to do is we need to internally initiate or declare an ID, which is just an internal method or the variable name, which we'll call ID. So we will call the function like this: if the member ID. So we need to first check whether the member already exists or not, because if already exists, we can skip that or adding a member. So this might happen when an admin is already adding someone who is already there in this system. So to do that, we need to first check if the member already exists in the target ID. If the target ID is returned by the system is 0, it means the member do not exist and we need to add the member. So to add a member into the member system, thing we need to do is we need to declare the member ID. So to declare the member ID, what thing we need to do is we need to call this method and update it. It's called target member is called member ID. So member ID has to be equal to the member length. So remember the array where we are keeping the members is called members, and dot length will give us the length of the entire the array. So if the array size is, let's say, 5, which is starting with 0 1 2 3 4, so it will return 5 digit 5. So that can be stored as a new ID, because if we add this particular digit number, let's say 5, right, this will be 0, then 1, then 2 3 4. So of course the fifth ID would be the 5 automatically, so we need to add it automatically into the target member. So this is done. So next is, of course, the ID of the member's length can also be called here, so we can also store it over here like this, right? So this can also be done. So now we have the ID in the separate variable. We need to next increase the length of the member, right, to make sure that the new array or the new item we are adding is reflected into the new length. So I'm just, for the simplicity, I'm showing it like this. Otherwise you can always use members dot length plus plus, right? So I think I have this mistake everywhere. Okay, so we have the length updated. Next thing we need to do is we need to add a new object of the member into the members array, because right now we have just updated the length, we haven't added the entire object. So to add the object, since the member ID has been created, and so the fifth one or the fifth ID will be members 5, we need to actually add a member by actually declaring a new structure or declaring the structure variable. So to do that, simple, you can pass a JSON object as a parameter while initiating or creating the object of this. So member name and member since, these are the three things that you need to pass. So first thing is member, so it has to be like this, then comma member since, sorry, member since will be equal to now, right, because you are adding it now. And then the last thing left with the member now is the name. So you can add a name, member name. So now this object has been declared, and then last thing that you need to do is just check if this is not true. Means if this condition is not true, if the member already exists, then what will you do? So we'll put a small else condition, and we will actually get the ID of the member. So to get the ID of the member, you need to do is member ID, right? And then in the member ID, you need to part a target address, because if this is not equal to 0, then this has to be equal to the ID. So if this is equal to ID, take it in the ID variable, right? And then and create the new member array. So you can call it like member m is equal to members and whatever the ID you have just created, so that you can actually declare it somewhere if you want to use it, though it is not necessary. This line is optional, or you can just ignore it if you want. So we can always declare an event saying that membership changed, some new member has been added. All this can be done very easily. So this add member function is done. Next we need to do is just add a remove member, right? So of course remove member can also be executed only by the admin, and what we only need is just a target member address. So to remove the member, it's simple. First need to check whether the member exists or not. If member does not exist, just throw the exception. So we will say member ID, so you need to check the target member is equal to 0. So this is simple. It means that particular member does not exist. If the member does not exist, then throw the exception. Otherwise you can loop for the all the members till the end and ensure that you have shifted the entire array. So for example, so let me just write it down here and then I'll explain why and how it works. So we'll say if the member ID, so we just took the member ID back outside the the members ID array and put it in the I, and then from I till the end of this, right, till the member -1. Because why we want to do it with -1? Because from, let's say, if you are talking about if there are total 10 members in the system with starting with 0 till 9, right? So and you're deleting the member number 5. So what you want to do is you want to, so this will become 5 until the I is less than the total length. So total length is equal to, let's say, 10. So 10 minus 1 will become 9. So if the I is less than 9, you need to make sure that shifting all the I's. So if you like this, so it's simple. So we are shifting the all members to the position number 5. So members I is equal to members I plus 1. So this is simple. So you are actually shifting the adjacent next member to the previous position so that you can delete the member. So simply here in this loop, if this loop will run, the last element or the ninth ID number 9 will actually be free and it will be useless. So what we need to do is we need to delete the ID number 5. To delete an element from the array, you can use the function like this, members and whatever the members length -1. Simple, right? Because this way the last element will be deleted and the member dot length need to be updated. Or you can just put -1. That's it. So this is how you remove the member from the system. So we have added the member, we have removed the member, we have changed the voting rules. So now membership part is done. So I think next part left, or the four methods left, are just a new proposal. Check the proposal code to check whether the integrity of the proposal is being maintained or not at the time of the execution, and then take the vote and then execute the proposal. So these are the main methods left. So to add these methods, first thing we need to do is just let's focus on the add a new proposal. So adding a new proposal is simple. There are a few things that you need to ask from the user. First thing is the address of the beneficiary, whom that particular proposal should transfer the fund. So let's say beneficiary, we're calling it a beneficiary only. Then next is the how much amount that particular proposal wants to transfer. So I'm calling it an ether amount. Then what is the description? So there can be some XYZ description. Let's call it a job description. Job description is there. You can also check for the bytes code, or you call it a transaction byte. So this transaction byte can actually help you executing the function which are other than the transferring the ether. So let's say if you want to call some other methods, you can actually copy and paste the bytecode of the particular method execution and then execute the method. So transaction bytecode are important. Transaction. So I'm calling it a transaction bytecode. Simple. So now the transaction bytecodes are there, and of course you don't want to execute this method except by the members, so only members can execute. And also the returns will be, we want to declare the project ID, or sorry, the proposal ID. So when the new proposal will be created, the proposal ID will be returned, right? So all is set. So let's start creating the proposal. So we have the function method is declared. So first thing we need to do is we need to create the new proposal ID, because when the new proposal comes into the system, its new ID has to be created. So we need to create the proposal ID, which is equal to the proposal's length, and then we will update the length. So length, so this line is simple. First thing we need to do is we need to transfer the proposal length into the proposal ID, and post that increment the value of proposal length. Remember, post the transferring the value, the proposal length will be updated. So this is just kind of a merging the two lines of code into the one line. So this is actually equivalent to this line. Let me show you. Proposals dot length is equal to, that's it, sorry. So this line is, the both lines are actually same. So now, so we transfer the proposal ID, then increment or increase the proposal length. Then next thing we need to do is we need to declare a proposal object. So we'll create a proposal P is equal to proposals, and then we create it from the ID. So of course this will be initially null, so this will be initially empty, or all zero, all the parameter value will be zero, or the strings will be null. So we have actually put it in the proposal P, because proposals are nothing but an array of the proposal P. Next is start putting the values which you have just received into the P. So we will simple P dot recipient is equal to what, exactly the beneficiary. So simple. Next, P dot amount is equal to the ether amount. Next is P dot description is equal to job description. Next is P dot proposal hash. Yeah, so there is something called proposal hash that we have added. So proposal hash is actually the integrity check. So what we'll do is when the proposal will be received, we will put the SHA-3 or the digest of these multiple variables called beneficiary, the ether amount, comma transaction bytes into the proposal hash. So this means that all these three variables will be concatenated together, and the SHA will be created, SHA-3, which will be stored in the proposal hash. This will help us to ensure the transaction byte received at the time of the execution is safe, or is exactly what has been proposed in the proposal. Why we are actually doing this? Because we are not storing the transaction byte into the contract. The reason why we are not doing it, because the transaction byte code can be large and very large. So storing the entire transaction byte into the blockchain can be very expensive. So what we propose is we put the digest over here, and at the time of the execution, when the transaction byte will be entered, we will ensure that transaction byte is exactly the same at the when it has been entered into the proposal at the time of its creation. So we need to ensure that we are actually executing the same proposal, because we are not sure if the transaction bytecode at the time of the execution can be changed. So if it is changed, proposal should not execute. That's it, because it is a proposal which is having the specific transaction bytecode, so that we can propose, that we can solve. So this is very helpful for the security. So next is the voting. So next is the voting deadline. Simple. The voting deadline can be, whatever the voting periods in the minutes. So in the system. So what we'll do is we'll add it into the now, and whatever the debating period in minutes the system has, the contract has already, and then we will convert it into seconds. To convert into seconds, you need to like code like this minute. So it's minutes, right? So this way you can actually call it, convert it into seconds. So this is clear now. Next is P dot executed. Of course, you can check the list of whatever the parameters are required inside this in this. So we have to fill out all these things. So p dot executed is equal to always false here. Initially at the time of creation it will be false. So p dot proposal passed is also equal to false initially because it is just been created. Then p dot number of votes will be 0 because it has just been created, and then we can call it a num proposals because these are the number of proposals in the contract or in the congress, so we can just update it. So we'll say whatever the proposal id is there, and we have just increased it by 1. So we'll say proposal id plus 1. So this is the total number of proposals available in the system. So that's it. So we just have to return the proposal id, and that's it. So this is just adding a new proposal into the system. So now when the proposal has been created, let's create a way to check whether the integrity of the proposal has been maintained or not. So it's a very simple logic. First thing is we need to ask for 3-4 things. So first thing we need to ask is the proposal ID, because for which proposal you are checking the integrity we need to make sure. So let's call it a proposal number. And then next is proposal number, then a beneficiary, because to check the integrity you need to get all these 3 things from the function. So address will become the beneficiary, so let's call it a beneficiary only. And then next is the ether amount, so it has to be in the uint ether amount. And then the transaction code, so I'm calling it a bytes transaction byte code. So if these things are available, you need to check whether these proposals are maintained. And remember, this will be the constant because we don't want to change this value again and again. This return type will remain as a constant, and it will returns whether it is true or not. So we'll say boolean, and we call it a code checks out. So this is simple. If the code checks out is equal to true, it means the particular the proposal has been integrity is confirmed, otherwise not. So let me put it in the separate lines. So okay, so this can go there only. So idea is simple. First thing we need to do is we need to fetch the proposal into the p. So p is equal to proposals, and id has been given from the proposal number. So we'll put it over here. And now next thing we need to do is just return the comparison. We'll say p dot proposal hash if it matches with the SHA-3 of the whatever has been given. So remember, it order has to remain same. So beneficiary, ether amount, comma, transaction byte code. So sir, it is very important that you maintain the order. At the time of the storage, you have created this order, so we need to make sure that this order is same. Otherwise, the byte code, the digest will be different because digest also depends on the order. So this simple method will actually return if the particular code has been checks out or not. So now the only 2 things left are the vote, how to vote for a proposal, and how to execute the proposal. So once the vote is been done and the proposal so then when the votes have been voted properly, so after the deadline you can execute the proposal and then get it executed by anyone, either by yourself or anyone. So we'll continue that part in the third part of this, and then we'll in the fourth part and the next part after that we'll test out and execute this proposal. So if you have any questions or doubt, please let me know. Thank you.